When EMO starts up, it always starts up in the market view. In this particular case, we're looking at 19th of August 2014, trading period 25. But there are three other modes which are extremely powerful. In fact, they're really what eMarket Offer was actually developed for. In the forecast mode, eMarket Offer will solve up to 1 week, half hour by half hour, in the same way as the SPD model, which actually solves the real market solves. There are some differences. SPD is a linear model, whereas eMarket Offer is a non-linear model, but for the most part, eMarket Offer solves accurately. Power flows mode will solve for power flows, so that doesn't give prices and it ignores constraints on the grid for up to a week by half hour. And what we'll look at now are scenarios. So if I click on scenario and create, then I have the option to rename the scenario, but I'm going to accept the default name, and I can decide whether or not to model reserves. For high accuracy, it's necessary to model reserves. For high speed, leave reserves off. Auto SFT is a newer feature which we're still working on to get more accurate and is out of scope for this particular demo. So we'll hit the OK button and get eMarket Offer to solve this trading period. So what's happened is that eMarket Offer has taken all of the information that SPD uses for final pricing and has done exactly the same market solve. So it's optimized the market by minimizing the total cost of dispatch, subject to all of the constraints, using actual offers for energy reserves relating to that trading period. The average price calculated by the scenario was $70.09, and if we double click on the market to take us back to the market view, we'll see that the market average was $71.80. So not exactly the same, but certainly close enough for most purposes. Let's go back to the scenario and have a look at what we've got. So we might now decide that we want to play around with this dispatch. For example, we might be looking at the effect of an outage on the transmission grid coming up. So we would go up to circuit, or let's take equation, and if I double click on the freedom column to get the ordering that I want, either ascending or descending, what that's telling me is how close the constraint is to binding. So when it's actually binding, that freedom will be 0. Here's a constraint around the Arapuni-Kinleith area, which is quite close to constraining. So let's have a look at what happens if we change the limit on that constraint from 75 to 68. Here it is up here, the order's changed slightly. We need to hit the redispatch button to redispatch with that new constraint value. This may take a little bit longer because it's likely that this constraint is now binding. In fact it is. The freedom on that constraint is 0. And we can have a look at that particular constraint by zooming in on the island. And if I click now on the Constraints tab for circuit colouring, it will highlight in red circuits that are constrained. So here we are, here are the two circuits between Arapuni and Kinleith. They are running red, so they are actually constrained by that equation constraint which we saw before. And I'm expecting to see a price separation between those two nodes which is greater than what one would expect with losses. So the price at the Arapuni substation is 32, and up at Kinleith it is 75. So that's a large price separation which is caused by that constraint. Go back in and restore that equation constraint to 75. Remember to hit redispatch. And when we go back to the map, we'll see that it's no longer glowing red. I can change the view of the map, incidentally, by selecting a different view. Now, what would happen if I took generation out of the market? Remember that the unit tab shows us all of the offers, and I can change anything in here which is highlighted in yellow. So let's have a look at what would happen if we took the E3P combined cycle gas turbine plant out of the market. Let's simply make it inactive. Hit redispatch. And what we've seen is a big impact on the price. The average is now up around $205 just by taking that one station out. Mind you, it was generating at over 300 megawatts, so it's probably not a surprise. Let's have a look to see if that changed any constraints. It's brought that Arapuni constraint a little bit close to the binding. Let's have a play around with that. Let's set it down now to 65 and hit redispatch. Hasn't had much of an impact on the overall average price. But if we move down and have a look, we'll see that once again that constraint is binding. 96 at Arapuni, and on the downstream side at Kinleith, $224. So the price increase due to the constraint has increased significantly as we've increased the overall price in the market. So just to summarise there, by using scenarios we can do what-ifs on what happens if generator strategy changes, offer prices for example, what happens if reserve offers change, what happens if we take circuits out or modify the limits on equation constraints.